Hi, so today in this video we're going to be covering chapter 6.2, which is transformations of the logarithmic function. Now this is going to be incredibly familiar with you. Hopefully it strikes a bell in your head, rings a bell. It's going to be very similar to exponential function shifts, and it's going to be very similar to quadratic function shifts. More similar so to exponential shifts, since that's obviously sort of where we're coming from, especially since it's the inverse. But let's just get into it. So if we have something like log base 3 to the x equals y, we know that our first points, as we covered in our last video, my last video in our last chapter section, our first points are always going to be, so if we have something like 1, our exponent is going to be 0. Yes. And then if we have something like 3, our base, in this case, our y is going to be 1. And then if we have something like 1/3, it'll be -1. No, sorry. Wait. Hold on. Now I'm confusing myself. So, yeah, log base 3 x. Yes, so 1/3 is going to be at -1. Yes. For our x. It's basically, again, it's the inverse of our exponential equation, so we're just swapping our x's and y's. Now, with shifts, if we're moving to the right, I'm sure that you can guess, well, not sure, but I'm pretty sure that you can guess where this is going. X minus 2 is going to shift our graph to the right by 2. X plus 2 is going to shift our graph to the left 2. If we have, and these would have parentheses around it. If we have something like -2, that would shift our graph down by 2. If we have something like +2, that would shift it up by 2. If we have something like 3 times our logarithm, that will stretch our logarithm by 3. If we have something like 1/3 times our logarithm, that will compress it by 1/3. Oh, well, by 3, I guess, by a factor of 3. If we have something like log 3 to the -x, that will flip it across the, hold on. I lost my graph. Across I think the y-axis. Yeah. It will flip it across the y-axis. If we have something like, like negative log base 3 to the x, it will flip it across our x-axis. This is very, very similar to what we've been doing before. If we have like 1/3 is our base, it's going to look a little bit like how our exponent was before. Whoops, hold on. Base 1/3 underscore. Sorry, I'm trying to figure out Desmos. 1/3. Yeah, okay, basically, it's sort of like what happens to our exponential graph, where it just kind of flips it a little bit. Sorry for the wait. Yeah, so those are our main transformations. I just wanted to get them, make sure I had them right. We'll just go start into this. Log of the function f of x equals log 4 to the x is transformed by shifting it down 6 units. So we're just going to do f of x is equal to log 4 base 4 to the x. I would recommend putting parentheses around that, down 6, so -6. If it was transformed, which resulted, our function f of x equals log base 3 to the x was transformed, which resulted in the function being f of x equals log base 3 to the x minus 1. So it was shifted down by 1. Shifted left 6 units, you're going to have f of x equals log base 4 to the x plus 6. And be sure to put parentheses around that. That is a killer. The function f of x equals log base 2 to the x was both vertically and horizontally shifted, which resulted in the transform function f of x equals log base 2 to the x minus 5 minus 4. So it was shifted down, and it might be right or left, just do it accordingly. It was shifted down by 6 and right by 5. These are our typical shifts that we've learned before. The function f of x equals log base 2 to the x is transformed to be f of x equals 3 times log base 2 to the x. What happens to the point 1 comma 0 on the function f of x equals log base 2 to the x after the transformation? And they forgot their s there. That's kind of silly. So we have log base 2. And now we have 3 log base 2, which means that it's going to be stretched by 3, which means that our y is going to be multiplied by 3. So it stays as 1 comma 0. 2 comma 1. After the transformation, it will be 2 comma 3. And then graphing the transformation, we always stay at 1 comma 0. And then it will be 2 comma 3. And now our new graph will look something like this, where there's still an asymptote at 0. Shifting doesn't, multiplying doesn't change our asymptote. Shifting right or left does, however. If there's a lot of typos this time. If the parent function, g of x equals log 6, it means parent function, by the way, to the x is compressed by a factor of 4, shifted up for 1 unit, and shifted horizontally right by 4 units. What is the equation of the transform function? We know if it's compressed by a factor of 4, it'll be 1/4 times log base 6 to the x minus 4, because we're going to the right. And then up 1, so plus 1. This is our new transform function. Awesome. Awesome. If it's reflected across the x-axis, it'll be negative log 3 to the x. Awesome. Cool. However, this changes our y value. It makes it negative now. So we have positive 9, negative 2. Log 8 base 8 to the x is reflected across the x-axis. Again, that's going to be the same. Negative log base 8 to the x, and that will be f of x equals that. Awesome. Cool. We've basically been talking about this. If f of x equals log base 5, and the reason why I'm going through so quickly is because it should be feeling familiar to you. It's a different look, but it's the same type of thing as our previous functions. If f of x equals log 5, base 5x is reflected across the y-axis, what is the equation of the transform function? Log base 5 to the negative x. And f of x equals. Don't forget that f of x equals, or else it will be upset. Y equals might work too. Fill in the blanks to find what transformations were performed. There's a lot of typos in this book for some reason. On the parent function f of x equals log base 5 to the x to get the function f of x equals negative 3 log base 5 to the x minus 4 plus 1. So it looks like it will be reflected. The function has been reflected across the x-axis and stretched by a factor of 3. The function has been horizontally shifted right by 4 units and vertically shifted up by 1. Parent function f of x equals log squared x, log base 2x is transformed to f of x equals log base 2x minus 9 plus 4. Select all correct transformations that were made to the parent function. Okay, it looks like this minus 9 means that it was shifted horizontally by the right. So we'll mark this one. It looks like this plus 4 shifts up by 4 units. Doesn't look like there are any other transformations. So that would be our answer. If you have any questions, please let me I have one more question. If f of x equals log base 2 to the x is stretched by a factor of 2, reflected across the y-axis, shifted right by 2 units, shifted down by 2 units, what is the equation of the transform function? Now, this might be really overwhelming to you if you see, oh my goodness, there's so many, but it's actually not that bad. We know that we stretch by 2, so we'll start with the factor of a equals 2. 2 log base 2, because that's our parent graph, to the, it is reflected across the x-axis, so we'll do minus x. Shifted right by 2 units, so minus 2. and then shifted down units, so -2. Don't forget those parentheses. This is our new transformed function. If you have any questions, please let me know, and I will answer as soon as I can. Have a good one.